Good morning to one and all. This is part 3 of the Mohr circle. I myself, Akash Mohanty from the School of Mechanical Engineering, VIT University, Vellore. We have discussed about the Mohr circle in part 2, and in part 1 we have already discussed the numerical equations to determine the unknown quantities or unknown stresses in different planes. Now we will continue the Mohr circle for the another type of problem. So in this problem, a cube is taken and a oblique plane is marked. The vertical planes and horizontal planes are 90 degree, and the oblique plane is at an angle theta degree from the vertical plane measured in anti-clockwise directions. The vertical planes contains the normal stress sigma x, and the horizontal planes carries the normal stress sigma y. Both these planes do not carry any shear stress. Thus, both the planes, horizontal planes and vertical planes, are principal planes. In the oblique plane, the normal stresses is sigma n and the shear stresses is tau. Both these stresses are unknown quantities, and you can determine. To draw this Mohr circle, we have to mark the y-axis and the x-axis respectively. The y-axis carries the shear stresses. The clockwise shear stress is measured in plus y directions, and the anti-clockwise shear stress is marked in negative y-axis. Similarly, the normal stresses are marked in x-axis. If they are tensile in nature, they are marked in positive x-axis, and if they are compressive in nature, they are marked in negative x-axis. So here to draw the Mohr circle, we have to mark the vertical plane and horizontal plane in the first step. So the vertical plane carries only sigma x and the shear stress is 0. So from this center of the coordinate system, we have to mark the sigma x in x-axis. After converting the stress value into suitable coordinate system. So before drawing this Mohr circle, we have to choose a proper coordinate system to convert the stress into scale values. Now we will represent, or we will mark the vertical plane in x-axis. Similarly, this plane is called vertical plane. Similarly, we will mark sigma y in x-axis because the horizontal plane carries normal stress tau xy and shear stress of magnitude 0. So for this purpose, it is lies in the same x-axis. Now this point is called horizontal plane. By knowing vertical plane and horizontal plane, we will find the center of this Mohr circle is the half of the distance between horizontal plane to vertical plane. By knowing the center of the Mohr circle, we will draw the Mohr circle. Now our Mohr circle is ready. We have to mark the oblique plane. The oblique plane is measured theta degree from the vertical plane. Here in the Mohr circle, the horizontal plane and vertical planes are 180 degree, whereas in the question figure it is 90 degree. That means if we will take any angle from the question figure to this Mohr circle, the angle is multiplied by 2. For this purpose, if we will mark the oblique plane in the Mohr circle, the angle should be multiplied by 2. So from the vertical plane to mark the oblique plane, we have to multiply the angle theta by factor 2. So here from the vertical plane we mark 2 theta angle, then we will join this angle from the center of the Mohr circle, and we will get one point in the Mohr circle. So this point is a plane called oblique plane. In the oblique plane, as we saw, there is two stresses are there. One is normal stress, one is shear stress. So now we will measure the horizontal distance from the center of the coordinate system to this oblique plane. This is called sigma n. So after getting this scale value, we will multiply the suitable scale, we will get the sigma n values. Similarly, if we measure the shear stress, that is the value in y axis, and if we multiply the suitable scale, we will get the shear stress in the oblique plane. So this is the way we will get the oblique plane and the normal stresses which is acting. In the oblique plane also the resultant stress is acting. So if we will join the line between center of the coordinate system to the oblique plane, and we will measure these values in scale and multiply by the suitable scale factor, we will get directly the resultant stress value in the oblique plane. And the angle of obliquity, if we measure directly this value, will get the angle of obliquity. Here we have to remember that this angle is absolute, no need to divide by 2, because this is directly we can measure. Except this angle, all the angles will be divided by 2 if you want to take this value from the Mohr circle and represent in the question block. So this is the way we will draw the oblique plane and necessary stress values, and the maximum and minimum shear stress value at the two planes in the two opposite diagonal planes, and the angle between vertical plane to maximum this maximum shear plane is 90 degree, and the Mohr circle for the like stresses are finally looks in this figure. So one important observation is we have saw that sigma x and sigma y are 90 degree apart, but in Mohr circle they are 180 degree apart. So all the angle measured from the Mohr circle should be divided by 2 except the angle of obliquity. The two endpoints of the horizontal diameter are sigma 1 and sigma 2. The point sigma 1 represents the maximum normal stress, and the point sigma 2 is the minimum normal stress. The maximum and minimum shear stress will act at 45 degree to the principal planes. Now we will represent all the stresses in the question figure. So this is our question figure where there is a block is there, and the normal stresses are sigma x and sigma y are acting in vertical and horizontal plane. In vertical plane, the shear stress is acting vertical in vertical direction, and the shear stress in the horizontal plane is acting in horizontal plane as shown in the figure. So from this Mohr circle we will measure the angle of principal plane and we will mark like this. Similarly, from this is the plane where plane of major principal plane, the stress which is acting normal to this plane is sigma 1 and parallel to this plane is sigma 2. From this plane, the plane of maximum shear is 45 degree and the minimum principal plane is 90 degree. So in 90 degree from the plane of major principal plane, the another plane where the stress normal to this plane is minor principal plane, and along this plane is sigma 1. So these two are principal planes. From this principal plane, the shear stress is 45 degree. So from this 45 degree, if we mark, this is the plane of maximum shear and the other one is plane of minimum shear. For the practice, we can use this problem as homework. So here you have to calculate the following stresses analytically and graphically. So you can try to calculate the maximum shear stress, principal stress and its inclination for the given set of loading. There is a Q where the vertical plane carries tensile stress of 50 meganewton per mm square, and the shear stress in the vertical plane try to rotate the cube in anticlockwise manner of the shear stress of magnitude 30 meganewton per mm square is acting. Similarly, in the horizontal plane, the shear stress is in clockwise direction, the normal stress is in compressive in nature and the magnitude is 30 meganewton per mm square. So we have to, you can practice for this problem for maximum shear stress, principal stress, and their inclinations, that is the angle at which you are getting the principal stresses and the angle at which you are getting the plane of maximum shear. Thank you.